Hello everyone, this is Mr. Ahmed Al Qadri, and today we will continue our lesson about work and energy. And today we will talk about energy and the forms of energy. Okay, guys, before we start our lesson, remember this person was pushing the car in the last videos. So right now you can see this example. If I want to ask you a question, are you able to push a car? Okay, so many students of you, they will answer maybe yes we can and maybe no. So here, if you have enough energy to push this car, absolutely you want to say yes we can push this car, or no we don't have enough energy to push this car. That means in general, energy is the ability to do work. So here, as you see, energy is the ability to do work. Like work, energy is measured in joules. And we have two kind of energy, two important kind of energy: potential energy and kinetic energy. A potential energy is energy that's stored in an object or a materials, and kinetic energy, a moving object, also has energy because it has mass and speed. So the energy of motion, when I have any object move, okay, so it's called kinetic energy. So example of potential energy are stretched rubber bands or wound up springs, stored energy because of their elasticity. A rock on the edge of a cliff stores energy because of its position and the force of gravity. Okay, right now I want to tell you exactly what is a stored energy, a potential energy. So you can see this mass right now. It's an object, a mass. Okay, we hang it with the spring constant. You can see right now, if I stop the uh, the spring right now and the object right now here, I stop the motion of it. So right now I have energy, but is it stored inside the spring? When I stretch the spring again one more time, and I will leave the spring, so the spring starts what, up and down moving. So I have a stored energy, and I use it after a while of time. So another example of potential energy is the skater right now, right here. So this the skater has a potential energy, it has a stored energy inside him. So you can see the height from the ground, because if he jump to the ground he make damage. So he has enough energy, potential energy. As you see, if he start his potential energy, this is a potential right now, he doing a skate on this shape, U shape. And of course, for examples for the kinetic energy is all the objects, if they are moving, that means they have kinetic energy. So objects with greater masses or higher speeds have greater kinetic energy. All energy is either potential or kinetic. So energy often changes from one form to the other. When a roller coaster first moves over the top of a hill, it travel slowly. Most of its energy is potential energy. A roller coaster speed up as it starts down the hill. At the bottom, the roller coaster is at its highest speed. Most of the potential energy is changed to kinetic energy. However, this change in energy is not the end of the ride. We want to take as example the skater here also. And I want to put here the graph that how it's the kinetic energy right now and the difference, the change between kinetic and potential energy as example. You can see right now that kinetic here is at the top of the hill as example the skater, and he has, you can see, the potential energy is high, the highest, and the kinetic energy it's zero. Okay, and if we want to make, if we want to let the skater move, so you can see the change between the two energy right now. When he, right now here you can see at the bottom, because he's go down very fast, he has a maximum of kinetic energy and zero of potential energy. Why? Because right now he is on the ground, so the potential energy is zero. Okay, guys, another example of energy is thermal energy. Thermal energy is the heat energy in an object. So, as example, the friction between the track and the roller coaster cars change some of the total energy to heat. This thermal energy can warm the track. Another example of thermal energy, when you are running and you gain thermal energy, or your actually your kinetic energy transfer or change to thermal energy. So right now we want to talk about conservation of energy. All forms of energy have a source, a means of transfer, and receiver. For example, in a flashlight, the energy source is the potential energy in the battery. An electrical circuit enables the energy to be transferred to the bulb. So the bulb is the receiver of this energy. It can then give off energy in the form of light and heat. So energy change from one form to another, but energy cannot be created or destroyed. So the most important idea about the energy is energy cannot be created or destroyed. Scientists call this the law of conservation of energy. We will go back to our experiment. We do it in this section. Okay, guys, let's see, this is the potential energy and this is the total energy, okay? Because the total energy is kinetic plus the potential energy. You can see how, in this example, how the energies cannot be destroyed, okay, or created. So I have potential energy right now. Look at this graph right now. I have kinetic and potential together. But look to the total energy I have. It's look maximum, always, all the time maximum. So this is what we mean by the energy cannot be destroyed or created. The energy change between kinetic and potential. This is the law of conservation of energy.